Hello everyone. Today we're going to talk about Majorana1, a new quantum chip from Microsoft. What is quantum computing, the technology behind it, how it compares to other quantum chips, and more. Microsoft, a leading technology and innovation company, recently unveiled Majorana1, a new quantum chip that promises to significantly advance quantum computing. This development is an important milestone in the search for computing solutions that overcome the limitations of traditional systems, with revolutionary potential in areas such as cryptography, chemical simulations, and artificial intelligence. What is quantum computing? Quantum computing is a new frontier in computer science that uses principles of quantum mechanics to process information. Unlike classical bits, which represent zeros and ones, qubits can exist in multiple states simultaneously, allowing quantum computers to perform complex calculations exponentially faster. Majorana1 is an attempt to harness these principles to create more stable and scalable quantum systems. The technology behind Majorana1. Majorana1 uses a novel approach based on particles called Majorana fermions, which are their own antiparticles. This characteristic is key to creating topological qubits, which are less susceptible to errors and noise, one of the main challenges of quantum computing. Microsoft believes that by exploiting these particles, it will be able to build a quantum system that is more robust and reliable. Comparison with other quantum chips. While other companies such as Google and IBM have focused on different approaches to quantum computing, Majorana1 stands out for its emphasis on topology. This difference could provide a competitive advantage, as quantum chips based on topological qubits have the potential to operate at higher temperatures and with greater resistance to external interference, increasing the practical viability of quantum solutions. Potential applications of Majorana1. Majorana1's impact could be far-reaching, ranging from improvements in encryption algorithms that ensure the security of digital transactions to advances in simulations that could lead to scientific discoveries in fields such as chemistry and materials physics. In addition, the ability to process data more efficiently could accelerate the development of artificial intelligence, creating smarter, more responsive machines. Microsoft's role in the quantum community. Microsoft is not only a technology manufacturer, but also a major contributor to quantum computing research. The company is investing in partnerships with universities and research institutions to explore the applications of Majorana1 and expand our understanding of quantum mechanics. This demonstrates its commitment to not only leading the market, but also contributing to the advancement of science. Challenges and future perspectives. Despite the exciting promise, quantum computing still faces significant challenges, including the need for controlled environments and minimizing errors. Majorana1, while promising, is still in the development and testing phase. Microsoft is aware of these obstacles and is actively working to overcome them, with the hope that quantum computing will become an affordable reality in the near future. The launch of Majorana1 represents a significant step forward in Microsoft's journey toward quantum computing. With its innovative approach and industry-changing potential, Majorana1 could not only redefine what's possible in computing, but also open up new opportunities across disciplines. As Microsoft continues to explore the boundaries of quantum technology, the world is eagerly awaiting what the future holds. Now, I will talk about the difference between quantum computing and classical computing. The difference between quantum computing and classical computing is fundamental and is based on how each one processes information. Here are the main points of distinction. Unit of information. Classical computing uses bits as the basic unit of information, which can be either 0 or 1. Quantum computing uses qubits, which can represent 0, 1 or both simultaneously due to the principle of superposition. Superposition. Classical computing, a bit has a defined state, 0 or 1, at any given time. Quantum computing, a qubit can be in multiple states at the same time, allowing a quantum computer to process a large amount of information simultaneously. Entanglement. Classical computing bits operate independently. Quantum computing qubits can be entangled, meaning that the state of one qubit can depend on the state of another, even if they are separated by large distances. This allows for correlations that do not exist in classical computing. Parallel calculations. Classical computing performs calculations in sequence, which can be inefficient for complex problems. Quantum computing, thanks to superposition, a quantum computer can perform multiple calculations at the same time, offering potentially much greater speed for certain types of problems. Errors and noise. Classical computing. Although classical computing can be affected by errors, the systems are generally more stable and less susceptible to external disturbances. Quantum computing qubits are extremely sensitive to interference, which makes error correction a significant challenge in quantum computing. Applications. Classical computing. It is effective for a wide range of general tasks such as word processing, financial calculations, and games. Quantum computing. It has the potential to solve complex problems that are intractable for classical computers, such as simulations of molecules for drug development, optimization of large systems, and breaking cryptography. These differences make quantum computing a promising and intriguing field, with the potential to transform many industries and solve problems that are currently beyond the reach of classical computing. While quantum computing has great potential, it faces several challenges. Decoherence. Qubits are susceptible to losing their quantum properties due to interactions with the environment, which results in loss of information. Keeping qubits in a coherent state long enough to perform computations is a significant challenge. Error correction. Due to the fragility of qubits, it is necessary to develop robust error correction techniques to ensure that calculations are accurate. This involves creating quantum codes that can correct errors without directly measuring the qubits. Scalability. Creating a quantum system with a sufficient number of qubits to solve practical problems is a technical challenge. Building scalable quantum computers that can be used commercially is still under development. The future of quantum computing is still in its early stages, but companies like Microsoft, IBM, Google, and others are investing heavily in the research and development of this technology. The expectation is that as challenges are overcome, quantum computers will become more accessible and integrated into everyday applications. Quantum computing represents a paradigm shift in the way we think about information processing. With its unique capabilities and potential applications, it could revolutionize industries ranging from medicine to cybersecurity. As technology advances, it will be fascinating to see how quantum computing becomes an integral part of our technological world. Our video has come to an end. I hope you enjoyed this information. Leave your like and subscribe to the channel to continue receiving more content about technology and science. Thank you.